Section 4.6, rank. The row space is the set of all a linear combination of the row vectors, and it is denoted by row of A. So for an n by n matrix A, row space is a subspace of Rn, and row A is nothing else but the transpose, the same as the column of A transpose. So here how it goes. If you have a matrix, some kind of matrix, let's say that we have 3 by 5, 1, 2, 3, 4, 5, 3 by 5. So this matrix is 3 by 5. So this is my m by n matrix. If I take the first row, the first row has 5 coordinates. So this is my 1, 2, 3, 4, 5. So because each vector has some 5 coordinates, that's why it is of the R5. So that's the second one. That's why it's a subspace of Rn. We write the row vector horizontally. So the row vector is x, and we write it horizontally. And the column vector we write as a column. If two matrices A and B are row equivalent, then their row spaces are the same. If B is in echelon form, the non-zero rows of B form a basis for the row space of B, and the same as A. If the spaces are equivalent, then they are the same. All right, so we have a question, find the basis and state the dimension. We have row space, column space, and the null space. Column null space, we already know how to find it. Column space too. Now we are just adding the row space, how to find the basis of the row space. And because they are row equivalent, so if B is in echelon form, the non-zero rows of B form the basis. So pretty much the same. So first we're gonna solve the system to find the basis for the null of A. Solve the system, we've been doing this for a while already. And to find the basis for the column, we identify the pivot columns, right? So set up the equation, take the matrix, and equal to 0. So this is my matrix with the zero column. Perform row operations. Pretty much solve the system. Here we go. Pretty much, I would recommend that you pause the video and keep solving the system until you get the solution. Here's my solution. We have also the notes. So since those vectors are linearly independent, they going to the basis for the null space. I have three vectors. I have 3 vectors in the null space. So the dimension of the null space is 3. Now identify the column, the pivot columns. Pivot is my first and the third one. So we take first and the third column of the original matrix for the basis to the column space. So this is first column and the third column of the original matrix. Since I have 2 vectors, the dimension of the column space is 2. And now, as it was in this theorem, which says that the non-zero rows of the echelon form the basis for the row space. So this is my matrix in echelon form. This is actually reduced echelon form. So I have first row and the second row. So I can take first row, second row for the basis to the row space. So the basis for the row space is my first and the second rows. Since I have 2, the dimension is 2. Now we have definition. Now we have definition. Rank of a matrix is the dimension of the column space of A. So the number of the vectors in the basis of A. We find the dimension of column of A is nothing else but the pivots, pivot column. So how many pivots we have. The dimension of the, because pivot columns determine the dimension of the column space and also dimension of the row space. So column space and row space are determined by pivots. So they always have the same dimension, right? The rank theorem, the dimensions of the column space and the row space of the matrix are equal. That's just, I said this. This column, this common dimension or the rank also equals the number of pivots, pivot position of A, and we have the rank plus the dimension of null space is equal to n, total number of columns. So number of pivots plus the number of non-pivot free variable must be equal to the number of columns because there is nothing else left. And then we have questions kind of that make us think a little bit. So example 5 from the textbook, if you have a matrix 3 by 8 and A has rank of 3, find the dimension of the null space, row space, and the rank of A transpose. So if I have matrix 3 rows and 8 columns, and I know that I have only 3, rank is 3, so that means I have 3 pivots, 1, 2, 3. If I have 3 pivots, that means I have 5 free variables. So the rank of A must be the number of pivots, which is 3. That's actually given. Now, using the rank theorem, we can determine the dimension of null space, which is nothing else but the free variables. So the dimension of null space is 5. So pivots and not pivots, that must give you the number of columns, of course, right? So then dimension of row space is the same as dimension of column space, and let's call it rank, so that's 3. Rank of A transpose and A are the same, and that's equal to 3. Now we have example. Now we have example number 7 from the textbook. I have a matrix that has size 4 by 7 and has 4 pivots. So 1, 2, 3, 4. This is just a coincidence that we always had the same as the rows. Sometimes we might not. If we have only 3, 1, 2, 3, that means here would be zeros, all the row of zeros. So if this matrix has 4 pivots, about 7 columns, that means 3 are 3 variables. So the dimension, the question is columns of A are 4. Since we have 4 pivots, column is 4, and all of them has 4 coordinates. So indeed, column of A is equal to R4. This answer is yes. It's equivalent. Now, if you have null A, for this actually we should keep thinking that the basis spans R4, because if you take any vector from R4, you would have this B1, B2, B3. You're always gonna have solution for any B1, B2, B3. So that's why you can think that column of A spans R4, therefore they're kind of equivalent. Now for the null space, each vector in null space must have 7 coordinates. This is my x1, x2, x3, x4, x5, x6, x7, and then I would have 0 columns. So it has 7 coordinates, but R3 is a set of vectors with 3 coordinates. So vector with 7 coordinates can never be equal to the vector with 3 coordinates. So this is a little bit tricky question, good question for exam. If you have, because it suggests that you have 3 variables, so the dimension of the null space is 3, but that does not mean that it's R3. R3 is not dimension 3, it's 3 coordinates. So pay attention to that. And then we have theorem that if the matrix is invertible, then This means n by n because on the square matrices are invertible. If and invertible if and only if the columns of A form a basis of n, because if I have invertible matrix, I have n columns, I have n pivots, of course, right? If I have n pivots, that means for each B1, B2, B3, I always gonna have solutions. So any vector from Rn can be written as the linear combination of the columns, right? B3, B4, I should have 3, and here B4. So the columns of A do form the basis for Rn. They are kind of equivalent. We can say dimension of column space must be n. I have n pivots. Dimension of column space is called rank, so the rank is n. Null space has nothing in it because I don't have free variable, and the dimension of the null space is 0. So now we have example 19. Suppose you have 5 linear equations with 6 unknowns, and the solution to the homogeneous system are all multiples of one non-zero solution. Will the system necessarily have the solution for every possible choice of constant on the right side? All right, I have 5 linear equations, and first I'm working with the homogeneous, so that means it's 0 right here. And I know that my solution is a scalar multiple of one solution. What does that mean? That means I have only one free variable. I have 5 equations and one free variable, 6 variables. So that means I need to have pivot in each and every row. That's the definition of pivot. So yes, so if I have pivot in each and every row, then I can put B1, B2, B3, any numbers here, that's always gonna have a solution. So yes, the system will have a solution for every possible choice of the constant on the right side. So you can think if you just put the B1, B2, B3 as we keep doing it, and there is no contradiction, always there would be a solution. Now we have example 11. If the null space of an 8 by 5 matrix is two-dimensional, what is the dimension of the row space? So null space is two-dimensional. We need to think, what does that mean? Null space is determined by the free variables. So that means if I have dimension is 2, that means I only have 2 free variables. So in that case, I'm gonna, what is the dimension of the row space? Because I have 5 columns, 2 are free variables, so that means I have 3 pivots. Free variable and pivots must add up to how many columns you have. So if you have 3 pivots, then the dimension of the column space is 3, and the dimension of column space is the same as the dimension of the row space. So therefore, the dimension of row space must be